Our last one here, angle ADC. So I'm going to trace that in red. 54 plus 115 gives me an answer of 84.5 degrees, which again, if you add part A and part D, you should get 180 degrees. Okay. All right. Next one I'm going to go over is on next one we're going to go over is in topic 2, which is arc length and area of a sector. Make sure when you are working through these on your test that you are checking to see, are you solving in degrees or solving into radians? I'm going to real quick, just quickly review that with you. So maybe if you have a blank piece of paper, I don't have one, but I will write it somewhere for you guys, just real quick. Okay. If you're doing this in degrees, okay, for arc length, it's always the angle over 360 times 2 times pi times r. And then for radians, it's the angle times the radius for arc length. And if you haven't written that down somewhere, make sure you get that down. For sector, for degrees, the angle over 360 times pi r squared. And then for radians, it's 1/2 times the angle times the radius. Okay, so I'm going to do number 16. And it doesn't say which one you should do it in, but this is supposed to be done in degrees. So we're going to do, it's 8 congruent slices, so I'm going to do 1/8 times 2 times pi times 12. And I'm just going to multiply 2 times 12 and then divide that by 8. Oops, this is area, sorry. This is actually arc length that I just did. Not sure if you caught that. That gives me 3 pi. The one up top is 1/8 times 12 squared times pi, which gives me 18 pi. Okay. All right, the next one I'm going to go over is number 23. And again, if you haven't tried it, please pause the video. Okay, what is the area of the shaded sector? So again, this is in degrees. It has a degree symbol. So I'm going to go 50 over 360 times pi times 2 squared. 50 times 2 squared divided by 360. And I want to make sure in my calculator I'm hitting math, enter, enter. You can, if you are on Desmos, when you're typing this in, so 50 times 2, not sure where the squared symbol is, 2 on my, divided by, oops, 360. Oh, why aren't you ringing up? Yeah, I gotta use the Desmos calculator, that's why. Oh, wait, okay. So 50. Sorry, guys. Technology at its best. 50 times 2 squared divided by 360. You'll get a decimal. If you're doing Desmos calculator, if you hit this button right here by the number 1, it'll change it to the fraction of 5/9. So our answer would be 5/9 pi. What is the length of the arc? So again, same thing, 50 over 360 times 2 times pi times your radius of 2. I go back here, Take that exponent times 2, divided by 3, oops. And then 360, get out of there, get on the bottom. You're getting 5 over 9. Again, it doesn't happen all the time, but it just happened that both of them did the same. Okay. All right, topic 3, scale factors. Circle B is a dilation of circle A. What is the scale factor? So when we see circle B is a dilation of circle A, that means this is the image, and this is the pre-image. Okay, what did I multiply 3 by to get to 9? So 9 over 3, which equals 3. What is the length of the arc highlighted in A? So again, I can go 90 over 360 times 2 times pi times 3, which gives me 3 pi over 2. And I will even double check that for you. So 90 times 2 times 3 divided by 360. Hit that fraction. Yep, 3 over 2. Right, what is the length of the arc highlighted in B? Now you can set it up the same way, and instead of the times 3 right here, you can change that to a times 9. I have decimals, why not do it? You get 9 over 2. Or the other way you can do it is to take your pre-image's length arc and just times it by your scale factor. 3 times 3 is 9, 2 times 1 is 2, and put your pi. What is the ratios of the arc lengths? The ratios of the arc lengths are the scale factor. Okay, this means like if I put the first arc length, the image over the pre-image, if I were to divide them, I should always get the scale factor because it's a length. If it was an area, then I would put it's the scale factor squared. How does the arc ratio of the arc length compare to the scale factor? It's the same. Okay. All right. Next one that we're going to try is number 29. Okay, and these are in radians, okay? Han thinks that the arc length of circle A is longer. It thinks since the arc length of the circle A is longer, its central angle is longer. Do you agree? Okay, so again, we are in radians here, okay? So to find the angle in radians, we take the arc length divided by the radius. So 6 pi divided by 15. And then this one would be 2 pi divided by 5. Well, hopefully you will notice that 2 times 3, or 6 divided by 3, is 2, and 15 divided by 3 is 5, and that they are the same angle. Okay, so we should say no, Han is wrong. Disagree. Okay. Right. Next one I want to do, it says find the arc length with a central angle 2/3 radians and a radius of 6 units. And I'm also going to do the sector too, area of the sector, just to practice. And if you haven't tried this one, please try it, pause the video, and then play it. So again, arc length is the angle times the radius. So you are doing 2 pi, 2/3 pi times 6. 2 times 6 is 12. 12 divided by 3 is 4 pi. Area of the sector is 1/2 the angle times the radius. So 1/2 times 2 pi over 3 times 6, radius squared, 6 squared. So 2 times 1 times 2 times 36 is 72. 72 divided by 2 times 3 is 6, or 72 divided by 6 gives me 12 pi. Okay, hopefully this review helped. Make sure you do ask your teacher any questions before test day.